Welcome to this video to learn how to do PLS structure equation model with the R, and I'm following the book written by the author Gaston Sanchez. So the Gaston Sanchez is depicted all detail how to go about it. So this is a very good model that we are going to execute with R. This model is consists of, we can say, this is a technological adoption model, and this is the technology environment is influencing the perceived use and the perceived easiness of the technology. So whenever a new technology come, how it is getting adopted by that we want to see, and the perceived use and perceived easiness, perceived usefulness and the perceived ease of use of technology that develop an attitude towards that technology. So the attitude construct is getting influenced by these two latent variable, and the attitude is ultimately influencing the behavior, and on that basis the person decide whether to adopt that technology or whether to reject that technology. And we can see the technology itself is defined by, this is a latent variable, it is being defined by a group of items. Similar, the perceived usefulness is also uh, described by group of the items. So these all these are the latent variable are in blue circle, and the all the these items that is reflecting out of those is in the form of the yellow small boxes. So now we want to see the result, and we want to execute this model with the R. So let us see how we can execute it with the R, and the coding about that. So to execute in R the PLS, I'll be calling the library PLS PM. And if you cannot call it this library the PLS PM, so what we can do then, you can install that package with the command called, you can use this command install dot packages uh, PLS PM. So this is the way, by executing this you can get you can download this package in the R. Now let us see how we are going. So once you install that package through the library, you can call, and now let us see how we are going about the execution. So once you call the library PLSPM package into the console, then you can import the CSV file, consists of all the data input or the data headings. So the technological adoption model file that is there, that in my desktop I am importing from the desktop with the read.csv file.choose. So this will give us me a option to choose any file from my directory that is in my computer. So this is a very useful to import any CSV file. Once I import it, so it is getting assigned with the time. So now I want to see what are the headers of this technological adoption model file. So I got the first row of this file, and we can see the all the heading of this file. First 7 data is regarding the technological adoption from T1 to T7. Then from A1 to A2 is regarding the attitude. So the perceived utility or the usefulness from PU1 to PU5. Similarly, PE1 to PE4 regarding the ease of work. So all of us can see the behavioral part is from B1, B2. So once I import, I saw the data. Then how to go about this model preparation? So to prepare this model, what I have to do? So first I have to go about the technology. This latent variable, this is a, all of us can see that image here. If you'll go through this image, then all of us can see all of us can see technology is not preceded by any kind of latent variable, but perceived use and perceived is being precedent of this technology. So technology is influencing the perceived use and the perceived use. And technology does not need any kind. So what we are finding in this R coding, so we have put technology C000. So then I have done a mistake, like instead of perceived of is, perceived of use, you cannot put 0. So then rectified it by perceived of use, you first put 1, then put 000. So that 1 means it is preceded by the technology. Perceived of is also, you can see C100. So then that is also preceded by the technology. So once we create this two, then we saw the attitude. Attitude is preceded by the two more this for second latent variable, the perceived of usefulness, and the third latent variable perceived of easiness. So that's the reason. So the it is not being preceded by the technology, is not influencing directly the attitude. So that's the reason we put this coding C1 for the perceived of use, and C then again 1 for perceived of business, then 0 0. So that we can see accordingly. Can you see in that image also? If you'll see that image again, if you'll go to see that image, so in this image, we can see attitude is being influenced by perceived of ease and perceived of ease and perceived of usefulness. So here technology, we can see the technology is, so for each latent variable, we have put the different binary number, the on the basis of the use of the attitude being preceded by these two Latin variable, we are putting one for this perceived use and for perceived is, and for technology it is not directly, we have put 0, and it is not also being getting influenced by behavior, we have put again there as 0. So let us see the R coding for that. So we can see attitude this 0 1 1 0 0, and behavior as C0 0 0, then 1 0, because so the fourth latent variable for which we have put 1, because behavior is not directly being influenced by the other three latent variable, we have put 0 for that, we have put 1 for the attitude and 0 for it itself. So now we got this five latent variable coding. Now I'm creating a path for this latent variable. So to create the path for the latent variable, this TM path, our bind is being used to create the matrix of this all these variables. So we generate a matrix of it. Then we want to develop the path, this diagram, interplot path diagram in R. So if we'll execute this, then we'll can see the path that will be reflected in R, like so then what we'll see in the first figure. So it will generate a figure in this R console. In the case of R, you'll find the graphical user interface. So this is the model. Can you see here? Technology is influencing the use and the easiness, and this use and easiness is influencing attitude. Attitude is influencing the behavior. So this is the way this. If you'll see here, I can also show you how we can do this in this. Now, if I'll be using this inner plot, if I'll run, then all of us can see in the case of that it will generate this path model. So going back to this console. So we saw that it is creating a path model. Then we saw that uh, let us see. We saw that it is being oh, okay. So once we saw the this inner plot, the path model, then I have to create a time blocks. So time blocks will be on the basis of the database that I have imported. So database that I have imported, let me show that Excel file. So that CSV file that I have imported. So what you will find here. So can you see the CSV file? In this CSV file, we can see the heading. The first heading is respondent. Then from 2 to 8, the 7 headings are on the for the your technology. The next two heading are for the attitude. Like this usefulness, the 5 headings, ease of use, the 5 heading. So on the basis of this, I have developed this block. Can you see time blocks? List the first this technology construct is defined by the 2 to 8 column. Then the column this is usefulness, perceived usefulness by the column 11 to 15. Then 16 to 20, the column in the CSV file is defining the ease of use. Then C 9 and 10, these two are for the attitude, and C 20 and 21 for the behavior. So I develop a block. So first to develop the path time path is important. Then to develop this block, then you have to develop the whether it is reflective or formative. So if it is reflective, it is go by the repeated. So this um, A and 5. So this giving is the modes of the operation. So now we will execute the PLS coding, time PLS, this object I have created. The formula, this is the important formula. So this formula, the first it is taking the data. So the time data, what I have like a TAM data. Can you see through what read CSV I have assigned this with the TAM? So the first is the file. The second data is the regarding the path, the element in the case of the formula. Then the third element here the time blocks, and the fourth element is the mode is equal to TAM modes. Once you do this, so then by this got executed, if you put enter, then to see the output time PLS, you will see the description of the whole model. So here this is all regarding the description of the model, that and the how many data that, and so this outer model, inner model, path coefficient, latent variable, cross loading, summary of the inner model, total effects, unidimensional, goodness of fit, bootstrap result, data matrix, all detail. In the summary, you can also use the summary function to see all this. So let us see the plot of time PLS. If I'll execute the plot of time PLS, let me execute and let me see the result. So then you see the plot of time PLS. If I'll execute the plotting of time PLS, so if I'll run, just see in the graphic, then we'll see then all this whole path and their coefficient, their regression coefficient, that value is which is positively negatively affecting the attitude. So all this detail is being given. So technology influencing 0.4943, 0.5689, but we are finding the user views here. So the data which is being created for a particular sector, and for this particular user base, we are finding that it is negative, but it may vary for your database. So it's all depend on the data that. So next we want to see the this cross loading that is there in the data. So to see the cross loading, if you'll execute once time PLS what we have created. So this time PLS I'm using here the output, and we are doing the plotting of the loading out of that. So if I'll do this, if I'll run, so then I can see the output here, the graphic output. See, the technology is being defined by the different items T1, T2, that output. Similarly, the ease of use. Similarly, for the as a perceived of usefulness, then perceived ease of use. So we saw the loadings value is being also being shown here. So this is the way we can see the basic first thing what we have to do. We have to use this formula. This formula is very useful to get the time PLS output. So once we got the time PLS output, so then we can go about the, so let us see. Can all of us can see now? So this is very useful to see the result. And so this path, then the blocks, then the modes, then the PLSM. This formula, this is being used. So can you see the result here? Then you can see the loadings I want to see. So time PLS is my object. All this PLS result is getting stored here, term underscore PLS, and through term underscore PLS I want to see all the loadings value. So time PLS dollar, then cross loadings. I can see the cross loading of technology to technology. Then I can see the cross loading of PUs to PUs. So here the cross loading are, so I can see the cross loading, that result I can get out of it, and we can see a good cross loading values are there. So once we get the cross loading, then the outer model, all the weights and loading and communality or redundancy of this, that I can, so inner model regarding the coefficient and how they are influencing. So we'll interpret this model in the different yeah, your videos. So then, so you see here the, it is the time PLS unidimensional, it is giving us the Cronbach alpha and this Dillon Galton ratio rho. So eigenvalue, the first eigenvalue, the second eigenvalue. So like this we are getting the output. So can you see this is the output to see the, so I got here error, this is the output, here the square bracket was missing, so this is the output to grade the Cronbach alpha, and this is the output to grade my row. You can see how I'm calling the different columns from this outer unidimensional output. So then this is the inner summary. Can you see here the exogenous, only the technology is the exogenous, rest of the latent variable are endogenous, they are dependent on. So only technology is not depending. So because technology came out, that is influencing all these endogenous use, ease of usefulness, ease of use, the attitude, the behavior. These are the endogenous. So we can see, yeah. So you can see the number of cases here. The 48 cases are there, and the variable. We can see the size and all. So this is the way. If we'll put the summary of this PLS to get the entire PLS output, and you need not to do again and again individually. Can you see at the end of the output this inner model, outer model, cross loadings, then we can see the correlation, then we can see the goodness of it also. So this is the way we can have the complete outcome. And you want to get a subset of certain things, then see here, this is the way all the loadings that I want to get for the technology only. So this is the way I can get the subset, and in this to get for the other we can change this, and we can instead of you can put PUs or PEs, you can get the PUs and PEs data. So this is the way we can have a process, we can process a model and we can get the output, and we can get so see all this and all this coding are being given in this like you can see this codes, how this code to get the outer model, unidimensional model. Suppose I want to get the GOF, what I can put term PLS, then so GOF, so this will give me the goodness of it. I want to get the coefficient, so this is the way I can get the coefficient. So this is all about how we can execute a PLS path model with through the R, and we can get the output. So in future we'll understand how to include the moderating and mediating variable to do the activity to execute the program in R, and we'll also see the interpretation of the output in future videos. So thank you, thanks uh, uh, for your listening, and we saw all this output here, and we also saw the diagram or the pictures. So finally, so this whatever the loadings finally we can get from smart PLS, the same thing we can get it through R, and we can do it through the R also. So finally this is the all execution. Thank you. And